It is very unlikely that a person would be killed by touching a metal street pole. Street poles are typically grounded. Grounding means that any electrical current that may be present on the pole will be safely diverted into the ground. The purpose of grounding is to provide a low-resistance path for electrical current to flow back to the source in the event of a fault. This prevents the voltage on the pole from rising to dangerous levels, which could cause an electrical shock. There are several ways to ground a street pole. One common method is to connect a grounding wire from the pole to a metal rod that is buried in the ground. The grounding rod provides a direct connection to the earth, allowing any electrical current to flow safely away. Another method is to connect the pole to the electrical neutral conductor of the power distribution system. The neutral conductor is also grounded at the substation, providing a similar path for fault current to flow. The effectiveness of grounding depends on several factors, including the soil resistivity, the size and type of grounding conductor, and the quality of the connections. Soil resistivity is a measure of how well the soil conducts electricity. Low soil resistivity is desirable, as it allows current to flow more easily into the ground. The size and type of grounding conductor must be adequate to carry the maximum fault current that could occur. Poor connections can increase the resistance of the grounding path, reducing its effectiveness. In addition to grounding, many street poles are made of non-conductive materials such as concrete or fiberglass. These materials do not conduct electricity, which further reduces the risk of electrical shock. Concrete is a mixture of cement, water, and aggregates such as sand and gravel. It is a strong and durable material that is commonly used for street poles. Fiberglass is a composite material made of glass fibers embedded in a resin matrix. It is lightweight, strong, and resistant to corrosion. The use of non-conductive materials for street poles provides an additional layer of safety for the public. Even if the pole is not properly grounded, the non-conductive material will prevent the flow of electrical current to a person who touches the pole. If there is concern about the safety of a particular street pole, the local electrical utility company should be contacted. Utility companies have trained personnel who can inspect the pole and determine if there is any danger. The inspection may involve visual examination of the pole for any signs of damage or deterioration, as well as electrical testing to ensure that the grounding system is functioning properly. If a problem is found, the utility company will take steps to correct it, such as repairing or replacing the grounding system or replacing the pole with a new one. It is important to remember that electricity can be dangerous, and it is always best to err on the side of caution. Never touch a street pole that is damaged or appears to be in poor condition. Keep children away from street poles and teach them about the dangers of electricity. Report any concerns about street pole safety to the local electrical utility company. In addition to the physical construction and grounding of street poles, there are also electrical safety codes and standards that govern their installation and maintenance. These codes and standards are designed to ensure that street poles are installed and maintained in a safe manner and that the risk of electrical shock is minimized. The National Electrical Code, or NEC, is a widely adopted electrical code in the United States. The NEC contains specific requirements for the grounding of electrical equipment, including street poles. These requirements cover the size and type of grounding conductors, the methods of grounding, and the testing of grounding systems. The NEC also includes requirements for the installation of street poles, such as minimum clearances from overhead power lines and other structures. The Institute of Electrical and Electronics Engineers, or IEE, is a professional organization that develops standards for a wide range of electrical and electronic equipment, including street poles. IEE standards cover topics such as the design, testing, and maintenance of street poles. These standards are often used by utility companies and other organizations to ensure that their street poles are safe and reliable. Regular inspection and maintenance of street poles are essential to ensure their continued safety. Inspections should be conducted on a regular basis, typically every few years, to identify any signs of damage or deterioration. Maintenance activities may include repairing or replacing damaged components, tightening loose connections, and cleaning the pole to remove dirt and debris. Proper inspection and maintenance can help to prevent electrical hazards and extend the life of street poles. In addition to the information already discussed, it is worth noting some specific scenarios that could potentially pose a risk of electrical shock from a street pole. Firstly, if a street pole is struck by lightning, the surge of electrical current could cause a dangerous voltage to appear on the pole. While grounding systems are designed to mitigate the effects of lightning strikes, they may not always be completely effective. Secondly, if a power line falls onto a street pole, the pole could become energized with a high voltage. This is a very dangerous situation, and anyone who touches the pole could be seriously injured or killed. Thirdly, if the grounding system of a street pole is damaged or corroded, it may not be able to effectively divert fault current to the ground. This could result in a dangerous voltage appearing on the pole. To minimize the risk of electrical shock from these scenarios, it is important to be aware of the potential hazards and to take appropriate precautions. If you see a street pole that is damaged, leaning, or has any other unusual condition, stay away from it and report it to the local electrical utility company immediately. Never touch a power line that has fallen onto a street pole or any other object. Always assume that a downed power line is energized and dangerous. If you are unsure about the safety of a street pole, it is always best to err on the side of caution and avoid touching it. Also, consider the environment around the pole. For example, standing in water while touching a metal object significantly increases the risk of electrical shock. Water is a good conductor of electricity, and it provides a path for the current to flow through the body. Similarly, touching a metal pole while also touching another grounded object, such as a metal fence or water pipe, can create a circuit that allows current to flow through the body. Another important consideration is the type of clothing and footwear that you are wearing. Wet clothing can increase the risk of electrical shock as it makes the body more conductive. Similarly, wearing shoes with metal soles or heels can provide a path for current to flow through the body. It is always best to wear dry clothing and shoes with rubber soles when working around electrical equipment. Furthermore, it is crucial to educate children about the dangers of electricity and the importance of staying away from street poles and other electrical equipment. Children are naturally curious, and they may not understand the potential hazards. Parents and teachers should teach children to never touch a street pole, to never climb on street poles, and to always report any damaged or unusual conditions to an adult. In addition to the safety measures discussed above, there are also some advanced technologies that are being used to improve the safety of street poles. For example, some street poles are equipped with sensors that can detect when the pole has been struck by lightning or when a power line has fallen onto the pole. These sensors can automatically alert the utility company, allowing them to respond quickly and prevent potential hazards. Another technology that is being used is smart grounding systems. These systems use electronic devices to monitor the grounding system and to automatically adjust the grounding impedance to ensure that it is always functioning properly. Smart grounding systems can help to prevent electrical hazards caused by damaged or corroded grounding systems. In summary, while it is very unlikely that a person would be killed by touching a metal street pole, it is important to be aware of the potential hazards and to take appropriate precautions. Street poles are typically grounded and often made of non-conductive materials, which significantly reduces the risk of electrical shock. However, there are certain scenarios that could pose a risk, such as lightning strikes, downed power lines, and damaged grounding systems. By following the safety tips outlined above and by reporting any concerns to the local electrical utility company, one can help to ensure the safety of the community. Furthermore, advancements in technology are continuously improving the safety of street poles and reducing the risk of electrical hazards.